All right. Hey, everybody. Sorry for the late start today. Had a little something come up, so great to be here, though. This is our Monday live stream for Epiphyte, and we're making some great progress in spite of navigating vacations and all that kind of stuff. And for those of you who've tuned in for the last couple of weeks, we have really converged on got a couple more people joining. Wait 1 second here. All right, here's Will and Charles, the UT team fully represented. Hey, Will. Hey, Charles.
Hey, how are you?
Good. Sorry for the late start. Had something pop up real quick that I had to bolt and then come back. So it was just summarizing where we are. So we've had really good progress over the last few weeks. We really zoomed in on this monolith sorbent approach. And Will, your feedback and reassurance was awesome last week. So we're proceeding with that. We have a good way of repurposing our system in UPenn for that, as well as making some structural modifications for the new build at UT that are kind of an incremental design change. We have a couple of sorbents that have been recommended that we talked about a little bit last week that would work with a high heat wash coating process. Although, Will, you and I will talk through that a little bit more because you maybe even had some other ideas, but that's a matter of just picking something that'll work and ordering it from Stigma. And then the real key thing that we want to figure out, though, is this heating thing, obviously, which is really, really important that we get the most efficient system and the safest approach. And so we talked about some of those ideas last week. And so Ling has done some further thinking and looking at parts for that. Ling, I downloaded your little image there of product options if you want me to flash that at any point. But I thought we would talk through the heating part because I think once we get to something where we want to go with that, we start to get into sort of part ordering territory. And one of the things too, David, I told you I'm going to be in Pennsylvania at UPenn on September 19th. So
Yes, I thought you'd said the 18th.
I'll probably will get in on the 18th. The event is the 19th. But if you want to join that event, just because it'll be a fun CDR event, but it's also an opportunity for me to get into the lab and for us to, hopefully kind of push a little bit of a reset on being able to kind of make the changes we want to make to that system. So we can talk about that a little bit later, but wanted to flag that. All right, cool. So anybody have any kind of questions or thoughts before we go? Will, I'm curious, that was your first time jumping in, and again, your feedback was super awesome, and I can't wait to work with you on this. And didn't know if any interesting ideas just marinated naturally over the last week since we spoke.
Nothing new on my end. I think I still like the idea of those two different sorbents we're talking about, like the PEI and then also the MOF. Those are really the two big ones. Yeah, that's kind of where I'm still at right now.
Okay, fantastic, great. Well, let's get into it. So, Ling, what's popped into your head around? And if you want to summarize real quickly, kind of the issues that we're trying to kind of overlap with for the heating thing.
Yeah. So, do you have a picture of Epiphyte, like the HVAC thing that you can pop up on the screen?
So the system itself?
Yeah.
Okay. How's this one?
Because I just want to show people the, So this thing, this metal body. So we're talking about heating the inside, and so we're thinking about heating by convection, whatever that we put on the inside. So we're talking about like putting these ceramic monoliths inside, and they're like this grid-like structure. So I think convection heating would be the best. And in order to heat it efficiently, I'm unsure. Okay, so there's a power strip like near the bottom, so you can use that for scale maybe. But like I've never seen this thing in person, so I don't have a good sense of how big it is. But it feels big.
2 feet tall, right, David?
4 feet, yeah, 4
2
feet
feet.
tall.
Something like that. Yeah, the wide part of the box is 2 feet. By the way, I don't see a picture here.
Oh, do you guys see it?
I see
everybody else see the picture on the screen?
I see the picture.
Yes, I see the picture. So I'm just thinking, like, usually when I'm ordering mechanical parts, I have some calipers or like a ruler, some tape measure, and then I'm going around with to the part that's already there, and then I look at the dimension of the thing that I'm buying, and then I compare them and think about like try to imagine how big they're gonna be. And I'm unable to do it this time because I've never seen this thing in person. But anyway, so I imagine that like in this void of like this double cone shape plus the center, we're gonna have to try to recirculate air in as effective of a way as we can manage. And I was thinking that we do it with one or two fans, not too big because we don't want the air to push from one end to the other. So we're gonna have the dampers closed, and if the air is if too much air is being pushed in one direction, there's no outlet for it to go somewhere. So if people saw my post in the Epiphyte channel, what I was saying is to use a small fan and then blow it into the heating element to pick up hot or like heat thermal energy and then transport it around the inside void and potentially use a second fan to help bring the air back on the other side. Maybe I have no idea where to mount these things. We'll have to brainstorm. But like the idea is to push the air in a circle of some sort. That way, it doesn't. The air doesn't know. We want the air to have an idea of where to go and not be like, where do I go? And then just kind of gets dispersed. So besides the fan, I'm also thinking that we're gonna need insulation because it's a pretty thin metal, I believe. David can attest to that.
Yeah, it's like thicker than a soda can.
Yeah, we're gonna lose heat really fast, I think, if we're
It'll
gonna try
get
to
hot
heat.
fast, right to the touch. It'll get probably pretty damn hot without insulation on the inside or outside, right?
Yeah, but that's not so much the concern. It's fine if it gets hot to the touch, but the higher the temperature it is, and the bigger the delta it is from ambient, the faster it will lose heat, and the harder it will be to maintain that temperature. And we want it to go to like 80 or 85 Celsius. So, adding some insulation will significantly reduce the heating cost, I believe. But unfortunately, that's also pretty expensive to. It's expensive to add insulation.
I wonder if there's like a spray-on insulation or something that's not like a foam, but rather it congeals into something that's a bit more.
So I've been okay. So it needs to stand 80 to 90 Celsius, right? And that's pretty high. That's close to the glass transition temperature of some plastics. And if the spray-on thing that you're talking about can stand that temperature, then great. But most insulation that we use for the home is not able to withstand that high of a temperature. So I gotta look this up. But yeah, that's all I have to say. I since I haven't worked much with, well, I also haven't worked with much with like a high school budget or college budget of a project for a while. There's usually more money, so I don't want to like accidentally drop $1,000 in insulation just to figure out that it's not really feasible. So I like to hear other engineers' feedback.
I agree.
I do have a question about that. When the insulation hits that like Celsius limit, like the temperature limit, like it can't withstand it, what happens to the insulation?
Probably melt or burn.
Melt or burn. Okay.
Yeah,
and is it like?
It's usually like plastic, wood, fiber, rubber, like one of those materials.
Okay,
I'm just looking at just Googling a little bit some of the options for it, and there is a category of spray insulation that's called extreme heat insulation, which goes up to temperatures of 100. That's actually not that bad. Anyway, I'll keep looking.
100 what Celsius or
Yeah,
Fahrenheit?
it's not high enough. Maybe used in temperatures of -4F or 100F, so that's not even close to enough. So
Oh yeah.
I'll take a look.
Does the but so is it like so it, obviously it can't withstand that temperature. Does that mean it like provides it for a little while and it just degrades, or is it like just it's not has no use, like it doesn't even affect it?
We would like to find an insulation that can withstand 80 to 90
Right.
degrees Celsius. Yeah. Well, I don't want to use an insulation that doesn't have a operating range of up to 85 or 90.
I think from the gist I'm getting is that it breaks apart pretty quickly. I was just wondering if it's like a slow degrade, if it is something we can swap out, but no, never mind. Ignore me.
Unsure. So usually I think it might come with adhesive, and adhesive will fall apart really quick at high temperatures, like 60, 70 degrees. That is still a problem. So that is still a problem with insulation that can withstand higher temperature. Like if it's like adhesive stick on, and I thought about lining both the inside, not both the inside, but with lining the inside or the outside with insulation, and both of those are feasible. So adhesive tends to start peeling at around 60 or 70 Celsius. That's like most, I would say like acrylic adhesives, which is pretty normal. We could like maybe tie it together if that's the case, because we don't need it to be like perfectly on sticking, like air, what's it called, airtight, watertight all the time.
Right.
What we needed to do is just to prevent heat from escaping so fast.
I think J3ANX just mentioned something, and I found it simultaneously that I think is the same thing. It's called Pyrogel, and it's a super high heat, up to 650 degrees C insulation material used in industry. I have to find out what it's like. Is it goopy? Is it foamy? But that, and then he also mentioned Teflon. So anyway, I'll keep looking at that. But there's got to be something out there used for industrial purposes that can withstand that kind of heat, not resi or residential purposes. So we'll take.
I think with unlimited money, we can find something that can work.
Well, I mean, I'm very sensitive to cost since I'm the one who's trying to keep the money to make sure we stay on budget. So assume that that's what I'm not going to pay a ridiculous amount of money for high heat or high cost insulation. But yeah, good instincts.
Just from a general search, it looks like Pyrogel is like, if you're doing 10 millimeters thickness, is like $21 per square. It doesn't say. Oh wait, this is really bad. It just says per square, not inch or foot. So I don't know. 1 second.
Okay. I bet you it's foot if it's for industrial purposes.
It is foot. Yeah.
Yeah. So that's not.
And
crazy.
it looks like it's like a blanket thing. Like it looks like a cloth thing, kind of thing. I don't know.
That would be great. Cloth's better than foam. I don't want to spray a bunch of foam inside of this thing. But anyway, sorry. Go ahead, Lane. Just wanted not to go on a tangent.
So I don't have much to say, but I just thought of something. I did mention in my messages in the Epiphyte channel that if insulation is a big concern, it is probably more effective to change the format, like the form factor of our duct, because right now it's not very conducive to lining it with insulation. Whereas if we want to unit test something where we're circulating the heat, or not even need to recirculate the heat via air, if we want to rely more on like radiation or conduction, it is possible with a much smaller size. So I was against conduction, but that's just because we were going to have such a huge amount of what's it called? Ceramic monoliths. But if we have a small piece of monolith, then it's possible to rely more on conduction. It's more size dependent.
Yeah, I think just a couple of things on this is I think we should, consider that every every DAC machine is made out of metal. So it's probably okay that we do this. I like this family of parts because they're off the shelf, and what they're built for has a lot of overlap with what we're trying to do. Airflow and stuff like that, and fitting filters in and things. And when you look at the original Thursday from Octavia, it looked like this for a reason, and then seeing another one from another DAC company independently looked almost exactly like this. So I think there's a lot to be said about staying with this general form function. But if some other thing sort of pops up that looks, incredibly enticing or interesting, we can obviously entertain that. But so that's all I had to say on that. But
Okay. Yeah, it should just be practical and not because everyone's doing it.
Well, there's probably an overlap between those two things. I think that DAC companies are probably very practical, I would imagine. So, but again, if something comes up that we see that looks better, then let's always keep our eyes open to that. But in the near term, when we're thinking about fixing this one and then building another one very soon at UT, if we go back to the drawing board on form function, that'll take a lot of time. But anyway, that's just thinking out loud here. Did you have something, Ling, where you had some parts even, I think, listed and some pricing out with the fan?
Yeah, so I mean you can pull those up. So there's just fans that I found in DigiKey. There's nothing like too crazy, but they are just a bit more temperature resistant. So if anyone is on the Epiphyte channel, you can find that list there. Sorry, it's not a great screenshot. It's not like the whole thing, but you can. There's like the part numbers there. This is DigiKey, by the way.
Okay.
You can just do a search for fans that have a higher operating temperature range, and I believe these go to like 87 Celsius, about 87 Celsius.
Yeah.
So it cuts really close. It's not ideal. I prefer something that goes to like 100, but it's harder to find.
And would that go, Ling, in just the 30-degree angle there, or 45-degree angle?
Yeah, something like that.
Okay. And you do one on both sides, or just kind of one? What do you think?
Maybe one on either side. You can just do one. You could do two, but you wouldn't do it symmetrically. You would place them strategically.
Could you, given the lack of space, would it make sense? Because we'll talk about the heating coil itself at the end of last week's call. We looked at something kind of like this, the one on the right-hand side. So I'm wondering if you had something where, just for space reasons, if you put the fan on the right-hand side of this on the slope, and then the heater, as we were thinking, on the other side in the same place.
Do you have a part number for the heater?
I don't have it because unfortunately that's what a lot of these websites are, just like contact for quote, even though they're
that's fine. I mean, I don't need to get the quote. I just need to get a closer look at the item and look at the specs.
Yeah, let me try to find that in a sec.
Okay.
But do you think, just real quick though, on the fan, does it make sense? I mean, the other thing we could also do is.
Well, I'm asking you for this part number because I gotta look at the heating element more to get an idea of if it works.
Let me grab it.
So originally I was thinking about blowing the air through a heating element to pick up the heat and then recirculate it around. It could work on the other side as long as the heating element doesn't block air. If it blocks air, it's like practically a deal breaker.
Yeah. So I thought if we had something that was really coily, either like, sorry, I'm trying to get on the screen. It's like one of these guys that's flat, that air flows right through it, or something that's more, a bunch of coils. I think I think that was why Kirsch recommended it. Let me again see if I can get the part number. Give me 1 second here. So if I share my screen real quick, where the hell is it? Oh, here it is. Okay, sorry. So if I share, if you take a look at this and this and this. Okay. So this was the one that I was just looking at here before. I could try to find the part number, but you see how that's got like a lot of empty space in it?
Mhm. Yeah, that's fine.
So that looked pretty good. I gotta see if there's a part number. Yeah, they don't give a lot of info here.
Wait. Can I just see what the website is? I'll just. Oh,
Yeah, I'll put it in right now. I'll drop it in
I
the chat.
what?
Yeah, I'll give you the exact link though to that because they sell a lot of stuff.
I'm sure I can find it easily.
Yeah. There you go. So anyway, something like that could be interesting. Let me stop sharing. And then if we had, again, I don't know what's optimal from an airflow perspective. If you had like the fan angled on the top part and then the heater below it, or if you had them, you said strategic. I don't know the first thing about what would be the best to make in that regard. But
yeah, just placement. But we do want to make sure that like things will fit inside the duct and not we don't run out of space. That's the first order of business.
Yeah. Well, I want to show, if I could, David, just to catch up on last week, and it's related to this because it's like, obviously what we want to do is we want to be able to repurpose the existing one, right? And then we also want to be able to optimize and make some changes to the second one, but have them be more or less versions of the same approach so they don't diverge completely. And so one of the things that I found, I was also thinking, I read a little more about that void factor or fraction that Kirsch was talking about. The less air you have in there, the less you vacuum, I guess was what was said. But what I was looking at from the same supplier yesterday, and really for the same cost, I think this one's about $20 difference, is that the one on the left is the one that we currently use, and that's got a 4-inch filter box. So that limits, that forces into certain directions in terms of how much monolith we could put in there. The other one here on the right has a 6-inch, right? It's actually 8 because it's for a 6-inch HEPA filter and then a 2-inch MERV filter. So we could put more sorbent in there, and it has less air, but it has some air, but it's a lot thinner, right? Ling, you can see the cone there is much more compressed. So I don't know if that's too compressed or if there's something where you could just stand up a heater right in front of it. And I don't even know if you need a fan with that little amount of air. And then, David, one other thing is we thought not even creating some sort of special box, one thing that Ling brought up last week, but these are solid state cubes, obviously. You could just drop the monoliths in a row and stack them on top of each other and just put them in that space. That would probably work just fine. So anyway, just wanted to, this was all to give David sort of an update, but it's relevant to the heating system to the extent of what we designed to repurpose the UPenn one. And can it be translate over into a box that is a bit different? I think you're on mute, David.
Sorry, the ones in the corners wouldn't get any air. So maybe those 4 could go.
So the more I think about how monoliths are sitting inside this box, the more I want to get away from the idea of a filter box. It's just very limiting. Just because if we want to, we're in the proof of concept stage, and if we want to eliminate complexity to get information from the thing that we run, we also care about eliminating complexity from the shape of the box or things that are similar. We want it to be as simple as possible. Like Chris, I think it's a nice vision to have something that aligns with the industry of carbon capture, but we're just not there.
Well, yeah, but don't you think it's good to draw on what people who do this professionally do and to really consider what are existing things that we can buy, that we also have some experience with, that seems to be all going in the direction of complexity reduction to me.
But we need to learn. We need to do some learning ourselves, and the learning should not be done on something that like the professionals have developed. We may find that like it works a certain way, maybe great, maybe not good with a filter box, but it like because we're amateurs at this, it'll be hard to know why something works a certain way with something that is like a complex shape versus just like a box or a pipe.
But what would be our I guess one thing I would say, I'm curious, I want to hear from David and Will and Tom and Charles on this, but my instincts are almost exactly the opposite, that being a group of amateurs to be able to leverage professional expertise, particularly if it is linked to relatively easy to order and assemble parts, my instinct would be to go for that. And I also wonder what would be the basis of our decision making in the absence of that influence? Like what would we then decide to use instead of that? But let's first just get David. I'm curious, particularly from you, because you built the first one and handled it. But I'm curious with the new team, what they think on this point. Go ahead, David.
First off, I think that Ling has a good point about not necessarily being tied to decisions that were made in the past that might have been for reasons of expediency at the time. I don't know if we really have the expertise to come up with a better idea, whether that might be building it ourselves or just finding a different box shape. But I'm certainly open to that. I see a couple of problems with the cone thing, especially when you have the square monoliths. Getting the square monoliths to fit in and get air pass through them from those circular cones isn't the most efficient. Also, I'm a little concerned that the pen people aren't involved in this discussion in any way. I don't know where they stand now. I haven't had any contact with them in a while, and I haven't been in the lab. So I don't know whether they've already picked out a team working on it or whether it's still in the conceptual phase. But since we're making plans for them, it might be a good idea to get them involved.
Yeah, we definitely will. So I can reach out to Peter just to let him know where we are. He knows I'm coming next month. But I think one of the things that we want to do, like in an ideal scenario, is that we want to be able to make use and keep the UPenn one active. But we also, the huge benefit of UT is that we have 3 people on the call right now from UT who have relevant expertise. We have a good facility, and we have the ability in an unrestricted way to access it and make changes for it indefinitely, right? Which is not something we have at UPenn. So I'm kind of thinking I want the UPenn one to be active and to work and to learn from that. But I think to a certain degree, the next build is a bit more important because it opens up a lot more doors for us in terms of being able to access and change it. But point taken, David. Well, I'll reach out to Peter and just say, hey, I'm coming to, and can we kind of catch up in the meantime in terms of staffing and interest on your side, so that by the time I get there, we can have a group of people that join us in the lab.
Oh, also, if the reason to keep the existing filter box is simply to save the cost of buying a new one, it's a relatively insignificant piece of the whole thing price-wise.
Yeah, it was like $250, I think, or $240 or something like that.
I don't remember, but it's
yeah,
somewhere
around there. Yeah.
Yeah. So to be clear, I'm not insisting on changing the shape, but I think it should be based on what method we go with, and not like staying with this shape just because it's what we already have. I'm open to staying with the shape, but it should make sense with the approach that we take. And if we're gonna like pump hot air through it, and then we like find materials for the bomb, and then we find that it might not fit inside, then it doesn't make sense to stay with the shape.
Well, I think one of the things about the monolith that's really good is that you can get those, the it seems like there's a universal sort of 6 inches are really sort of significant in terms of the dimensions for it.
Yes, but now we got a large amount of space that we need to heat, and it's not efficient. That's the thought. Like we do want to reduce the total amount of heating that we're doing, or else it's like very laborious to heat up that space.
Yeah,
I'm just
that's
saying
why.
there's a lot of things to consider.
Yeah, is there less space though if you do something like this, right?
Well,
Or, wait 1 second. I'll
it's
just show you
harder
the
to
side
heat.
view here.
There's a
Let's
lot of dead space here.
no. Well, this would be the entire space would be full of monolith cartridges.
Yes, but okay, but like there's a lot of dead space here where air cannot get into the corners.
Yeah, that's another thing that David just raised, which is a good point.
Yeah. And there's not enough like runway for the air to circulate. Because like the openings are now, like we're married to these openings that are on the ends. If we're not married to them, why are we using this box? We can use a different box or container.
Is it if there's not a lot of space in there, open space, does that reduce the need for circulation? We obviously want throughput of air. You have the monolith, you have the fan.
We have to look at the dimensions of the thing that we're heating, and like it's not objectively less space that causes not needing to recirculate the air. It's the dimensions of the things that we're heating and the overall physics of how it works.
Right.
If a substantial problem is the fact that those corners have dead space, how difficult would it be to round the corners, to try to like indenture it that way and cut off that area?
It's not hard. They come in circular rounds. You can buy monoliths that are actually shaped exactly probably like that. So you could insert a disc. It changes the idea of drop-in cubes. The awesome thing about cubes, they could just sit on a flat surface and be stacked. So if we did something that was just a circular monolith that fit there, then we would have to figure out a way to put it in position. But
if you're really married to the idea of them having the cubes, but you don't, and because it would be difficult for those cubes for a round monolith. But I mean, like one thing you could do is if you round the corners of that kind of square shape, and then you make just kind of corner blocks, like you're describing them as these cubes that we make and we just stack into there. But we make like two that work as quarterback who work at like these rounded ends, while the rest of them are just simply square.
Yeah, we can make a stand for a round one, but then the question is, why are we using this filter box? What if we just use a metal pipe that's just entirely circular?
Oh, yeah. That's a good point.
Yeah, whichever. What is? Yeah, I mean, we'll go with whatever one we want to, because if you did a round pipe like that, you could easily fit on round dampers and a round fan, and it's
we just make a stand outside for it. It's a lot easier to line insulation on something like that than this thing.
Yep.
Yeah, I did look at PVC, and it's not gonna be able to, like, we're not gonna be able to make something like PVC work for like 80-90 degrees. That's where the glass transition temperature is. So we're probably going to have to go with something metal plus insulation.
Yeah. Will, this is a tiny little Epiphyte Junior that another member of ours made, basically for sorbent testing. So this kind of inspired us about a month ago to say, should we do a bigger version of that doesn't have a manual screw-on dampers, but could use a mechanical damper like we had, but kind of going in this direction. And then you could also possibly insert a longer circular monolith that just fit to it. It could be quite long in the barrel of that, right? Because the air will still flow through it, right? So you could kind of maximize the amount of, the width of a circular monolith that you could just insert right into it. So I'm open to it. What does everybody think, though? David, you seem to, I know you were interested in that idea. Ling's interested in it. But for Thomas and Chuck or Charles and Will, I'm curious what you guys think.
Yeah, oh, sorry.
Go ahead, please.
Okay, sorry. I think the first thing I'd mention is that I'm definitely of the philosophy of don't reinvent the wheel. Like whatever's established, kind of go with that, and then try and just build up from there. I do think if we're gonna start making it here at UT, we should definitely do like a circular one. It just seems like it'd be the best option in terms of the monolith itself, being able to insert it and then also get the heat flow with the air through it as well, and then just overall like ease. That's just kind of what I think, especially if we're going to do it from the ground up. Like we don't have one here at UT yet, and we're going to start. I think that'd be a good starting point.
Yeah, circular. You said.
Yeah, circular.
Yeah, I'm in the camp of if you're like, I'm not gonna be the person building this, but whoever it is should do what they feel like has the best chance of finding the balance between learning and also something that will work well.
Mhm.
We're gonna both learn, and like it's gonna be both a struggle and hopefully work somewhat well at the same time, right? We
Yeah.
gotta find the balance. And it should be up to the people who are building this. And I do have an opinion on, or like I can give you my observations on, like I'm not sure if this will work. Here are the reasons, but in the end, it's up to the people who are gonna build it, because you have the highest stake of spending time on this and spending day in and day out with this device.
Yeah. Yeah, so I agree with that fully. One thing I did just look up, Ling, is so we're not married to PCB. That was just the thing that in PCB, that's just what inspired it. They just ChatGPT, like, what are some very high heat alternatives to PCB pipe? And there's quite a few. One that sounds really interesting because of its insulation properties is there are ceramic lined pipes, actually, that are used for different industrial purposes. So the ceramic part would be useful if it's lined, because that would also have an insulation benefit as well. And then some of the other things that were mentioned are PPS, polyphylline sulfide, that can go up to 500 or 260 degrees C. Something called PEEK, PEEK. So it looks like there's some options we can look at.
Yeah, I'm open to all of those. I wish I knew more about more like carbon capture, relevant materials.
Yeah.
Easier to make a decision if you know everything, but
I think with the pipe, we want it to be cheap. We want to be able to meet the dimensions we have, and we want it to be able to have really good installation, both for the efficiency of it and then to reduce the high heat to the touch. Those are kind of the things, the parameters I think we're kind of will lead to our choice.
Mm.
All right, cool. Circle. David, but don't you think, David, the only thing I'm thinking about though is that you're right. So are you thinking, we talk to Peter, maybe we say, okay, we want to swap out the filter box and we want to pop in a pipe. I really want that to continue to be a place. And we need, again, it requires, sort of active partnership on the UPenn side, which they've indicated they want to do it. The summer's been a bit slow, but is that what you'd be kind of thinking, is like a sort of a swap out for keep the other components and then swap out, use a pipe?
Well, I don't know. We know there are already several things that we expect they'll be doing differently. The question is just how much, do they want to just start the whole thing over from scratch, or try to work partly with what's there? And I don't know what their thinking is on that.
Sorry, I just accidentally dropped off. I heard you say, I don't know what their thinking is on that. I was gone for 10 seconds.
On the whole topic of how much to keep and how much to swap out, and whether to start over from scratch.
Yeah. Well, let me reach out to him and tell him where we are right now. It's good timing since I'm coming there, but if we could get a call with him and some of the people that he suggested. I'm also in very close contact with Professor Wilcox as well around some other stuff. So it's summertime. It's particularly the second half of August, as we know, is hard, but I will give it a try. But I think we can get in touch with them certainly a couple weeks before I make it over to Philly. All right, cool. Awesome, Ling. Thank you for thinking through that. And that's an important choice we just converged on there. But
I don't think we settled on anything, but so I want to ask about, like, when are you guys hoping to start a build, and like general feelings about milestones of this next build? yeah, just wondering because, sorry, I'm like in my own world over here, and sometimes I'm kind of out of it.
No worries.
Sorry, was that question for?
Yeah, I think it's for
I
you
don't know
guys.
who it's for.
I'm gonna be very involved, obviously, but you guys are the ones who are the team and the facility.
Right.
So fitting it into your calendar, I guess. I'm ready to go whenever we've made decisions on parts, but it's up to you
Yeah,
guys.
it's not meant to be a critical question. Like, I'm not criticizing anybody. I'm just getting a feel as to people's timelines to see how much support I need to pipe into this, or if I need to push faster, do more research, or whatever.
So just for us, for like at the UT DAC team, the club picks up like the first. So we're a sub team of a larger club, like Native Missions Technology Club, and that club has their first meeting, I believe, the second week of classes, which is I can pull up the exact academic schedule real quick, but basically it's probably going to be the third week ish that we're going to start properly progressing and stuff like that. But that's the timeline that for when we have like a lot more people to work on it. In terms of receiving the parts, if we could have that before that start line, obviously that'd be like there's no like we have to wait for that meeting to confirm that we can start receiving the parts and stuff like that. That's just for like involvement and work and stuff like that. So that's I'll give you that would be about, hold on, I'm pulling it up right now. So it would be about classes start August. Oh wait, this isn't the right. Oh gosh, I was on 20.
UT starts at the 26th of the first official week of classes. So I'm guessing this would be like second week of September is when so something around there.
It'd be around like the 12th of September would be our meeting that we start properly working on it and organizing the work into different teams and having them start to do all that stuff. And they also are people who can be incorporated in the research of it all and things like that.
Okay. My head is swimming.
Sorry, let me say that in short.
Soon, I guess, is the answer. It's
soon, yes. Sorry.
Yeah. And okay, so you're saying that it would be nice to start receiving parts, but not required.
Yeah, but my point is that like, don't feel like you need to wait to start figuring out like all those pieces for us to be ready for them.
It's not that, but it's also just like, it would be good to have a strong, like to hear stronger opinions than the people who are building. And I know that maybe not everyone who might be building is currently involved in the club. That's fine. But like some people might later be like, why do we make these choices? And they didn't have a voice in what we chose. And it's chosen by someone who lives like thousands of miles away. So, how will they feel about that? Because I've gotten into that situations before where I'm on the receiving end of decisions.
I totally understand that. We do have sub-team leads that are involved of like in our previous like DAC machine, like with what, like I said, Will, for example, is the sub-team lead for chemistry. And then we had sub-team lead for like programming and different stuff like that. So if it would make you feel better, we could definitely set up a meeting with those people who would definitely give some more insight. And that's like 3 or 4 people in that regard who each have a pretty good insight of what like can contribute even before the meeting. I know that they'd be up to get into a meeting beforehand.
Yeah, I feel like we're somewhat far from a solidified list of items for the bomb because, to be honest, I don't consider myself an expert. Like I consider myself more like someone who's logical and like can think about a mechanical system as a whole, but not someone who is an expert with like what will work well for carbon capture. I don't think I'm that person. So, I'm only doing my best.
No, it's great.
I think it's been really good, really solid. And honestly, like you said yourself, you being able to approach it from a perspective of like, not what's standard. Let's look at this and see what's like the in depth of it. Like, I think that's a positive, not a negative. So entering from the outside, I think is a positive. New perspective is always good.
Yeah.
Thank you.
Yeah. So no, I think But if it would make you feel better, for sure, we can have those people
Mm.
talk about them with the design and stuff like that. If you want to meet them yourself, that's also, it would be great. But otherwise, I can also just talk to them. I'll both as an option.
Yeah, I think what would be cool,
Use
Thomas.
design reviews.
One quick thing on this is once we've convened, we've had the first meeting, you know, we're then in a position to sort of schedule these streams around when we can all get in the lab, you know what I mean? And people can kind of come and stuff. So I think it'll change a bit that way. But go ahead, Link. Sorry, you were going to say something.
No, that's all. Like just it'll be good to do design reviews. So like not one person makes a decision and then someone else is building without ever having to look at what the plan is.
Yeah.
I think a design review is a great idea. Like when we start reaching that conclusionary point, we can definitely get those subject leads in head to also be able to talk about it. I think it's a great idea.
Yeah. So, real quick, guys, I'll just show you something if I can. Is I just was like researching those ceramic lined pipes. Again, we want to do some research, but in terms of their heat tolerance and their cost. So this is one look at a ceramic lined pipe. This is another one. This is on Alibaba, which shows some of the pricing. I don't know what the unit is for it. But so anyway, it's definitely worth taking a look at. They're widely available.
Okay.
And it might be good. So
yeah, this is good to know. I'll look this up.
Okay.
Oh boy.
Thanks for finding that.
So is ceramic a direction we think we can?
Well, we just literally, the only thing I think is interesting about that is it has good insulation qualities, you know, on the inside, it's pipe. But there's other things that were mentioned as well, which I'll just pop in the chat from ChatGPT, where there was 4 options that they recommended. I said, what's a high heat alternative to PCB that has good insulation? And these were the things that it recommended. What did
I'm just worried about, carrying it someplace, dropping it, and it just shatters.
Yeah, totally. No, we don't want that to happen.
Yeah, that doesn't happen because you're probably gonna have electronic components connected to it.
Yeah, exactly. I know how much is connected, like the chemical and the electronics and all it incorporated into it, which it won't be a problem. You can be careful with it. Don't think that was just.
Yeah, I gotta put it on a cart like the other one.
Yeah. So,
yeah, for sure. Yeah.
So J3ANX. Type in how you pronounce that, just so I don't keep that.
The Jinx.
It was J3ANX, but he's and I found out he's in I can't remember where you're based, but you're in Eastern Europe, which is awesome. Always love to have different regions represented. This is what he was recommending here, PTFE pipe, and he said it can be sprayed. It's non-toxic, and so that is something to also look at. So PTFE.
Yeah, it's the non-stick pan stuff.
Yeah, it's like Teflon, which I'm also recommending. Yeah. PTFE.
Like for insulation.
Hey Chris, I had a quick question.
Yeah, go for it.
Is there any way we can get like a schematic or anything like design, like just some metrics for the one that's at UPenn here for us at UT, just so we can start brainstorming and getting an idea what the dimensions of the one that we're thinking of building here could be?
So there are CAD files in the Chris, do you have the?
Yeah, I'll get it.
The GitHub repo link.
Yeah.
So the CAD files I have the step files, and I also have I made them on Onshape, so I have the Onshape ones. It's like a SolidWorks clone, but it's online. It's on the web, and you can get a free account and use it. But you can also import the step files and look at it in SolidWorks if you have access to SolidWorks. So in that repo, if you go into the hardware section, you should be able to find step versions of things. I don't think the assembly is there. I think the assembly has to be through Onshape. But you know how to find me on Discord, right? I'm Box.
Okay.
So you can message me and ask me for stuff directly.
Okay.
And Chris can point you to meet also whoever, not just you, but anyone.
Yeah, just come on in, man, and hopefully we'll meet up again. I'm in Austin, guys. I can come down. Will, I was emailing with you. Sorry, I was in Sacramento yesterday for a lobbying day and been a crazy week, but
No worries.
we could meet up anytime for coffee down near where you are or whatever. But this is a PTFE pipe that I just was looking at that J3ANX was suggesting, which kind of fits the bill. Oops, sorry. This here. It's kind of what we're talking about, I think, right? It's up to 500 degrees C, I guess. And then he was mentioning that it could be, potentially sprayed with insulation. So anyway, it looks like we have a couple options.
This by itself will be much better than that aluminum thing.
Yeah.
Because plastic just generally is much more insulating heat-wise than metal. Metal is a conductor.
Yeah, exactly. Yeah. So anyway, there's some interesting things to explore there, which we can delve into a little bit. So anyway, all right, that's good. Talk about that. That'll be cool looking as well. Talk about it's like monolith from like a 2001 perspective, just like it's extremely simple thing. You know what I mean? And it also allows us. We don't think like we could use the same dampers. We could use the same fan. We could use the same sensors, right? Like it feels like it's.
If it's the same size pipe. As far as the sensors, we're unhappy with the CO2 sensors that we used.
We got the new ones already.
Oh, okay. Be interesting to see if they work. I think part of the problem might also just be where they were located and the turbulence of the air, which they're not designed for. So sometimes people will use these sensors with a little pump that pumps a sample of the air through a tube, so it doesn't interfere with the flow. It just sips a little bit through a thin tube. I think they did that with Violet.
So like a drip. David, if you looked at it here, just like take this as our little, where is it? As our little Lego version of what we're kind of talking about. If we had where those vertical pieces are, if that is replaced, that we just have mechanical dampers on which side, where would we put the sensors for this actually? Like relative to the monolith and the dampers?
I don't know. We'd have one on the input side and one on the output side.
So on the other side, basically on the other side on the extreme ends, probably, right? Just on the ends, the intros and outros of the dampers, I guess, right?
Right.
Okay. All right. Sounds good. All right. Does anybody want to do, where am I here? Does anybody want to do some research on the sort of the pipe options based on what I shared in there? I can keep looking around a little bit, but if anybody has any thoughts between those options, I'll copy and paste the links into the Discord as well that I was looking at. But the PTFE looks like a good option. The ceramic pipe could be a good option. Yes. Do you all have RH sensors?
Relative humidity.
Oh yeah, right. Okay. Yeah.
The sensors we used have that built in. I don't know about the new ones. I suspect they do also.
Yeah. So we're gonna have right now the bomb that's on the GitHub is for the old one, and it has the old sensors. It's got the old sorbent. As soon as we make our choices here that we're ordering, we're gonna go ahead and add that. And Ling, I guess we should keep that old bomb, right? Like as a version control thing, because we want to show
it's version controlled. Yeah.
Yeah.
I don't know I don't know what we'll do for maintaining stuff for the new version. I think at first we will not use GitHub for it. It's not as easily used by everyone. So we'll probably use some Google Docs.
Yeah, and then when we're finalized,
Yeah.
we'll update it.
I'll help look up pipes, but apparently Googling is a weakness of mine. So it'd be good if other people also do it because I might miss a lot of stuff.
Yeah. Will, is there any kind of chemistry? This is going to sound so stupid, but that's my job. Is there any chemistry sort of implications, I guess, of the pipe? Anyway, let me formulate that so I don't sound like an idiot. But I want to make sure that we put something in there that's not just the right heat tolerance, but that some other thing doesn't happen when you heat up and then the pipe gets hot and then that has some sort of chemical reaction with the sorbent. You know what I mean? You kind of get what I'm getting at here, right? However, I think that sounds, but maybe we'll have a few more options to look at next week, and we'll look at it through the lens of cost, dimensions, and if there are any chemistry implications. And then, we'll do that. But yeah, hopefully, and we'll meet up, Will, and maybe team here. We can, we'll get together between now and next meeting, or I can't remember, Thomas and Charles, if you guys are in town. Sorry, I keep forgetting.
I'm probably going to get in town 24th.
All right.
I'm also there to the 23rd.
Okay. I'll ping you guys on WhatsApp. At the very least, Will will meet up. Before we jump off real quick, Will, do you think maybe next week, or maybe we can do it the following week, because we might have a lot to discuss next week, but it would be cool to take a little bit of time on this call to sort of, I can even potentially come to UT. And one of the things that David and Chuck did when we went to UPenn, this was before we were live streaming, they went and did like a site walk of the UPenn lab, kind of took account of where things are, what sort of equipment and stuff. It'd be cool to do that relatively soon at UT, where we can, stream from the lab and sort of talk through our inventory and what we have and stuff like that.
Oh, definitely. Yeah.
All right, cool. So if not next week we're coming down to brass tanks on the heating system and the pipe. And then maybe the following week we can plan, because everybody will be in town by that point.
Yeah. Okay.
Cool. All right. Progress. Anything else before we jump off?
Chris, did you want to meet today by chance, or you still have time? I can also meet tomorrow. I'm free.
Yeah,
as well.
I probably could. I have my bill in California, which is an open air bill. It's the biggest thing I've ever personally worked on in my life. Is going to its final committee in the state assembly in a half an hour.
Okay.
And, but if I don't know how mobile you are, Will. Certainly if you wanted to come up to my place, we could do today, or we could do tomorrow afternoon if you wanted me to come down to UT.
Okay. I think for my schedule, it looks better for tomorrow afternoon, if that's cool with you.
Yeah. Let me just check my calendar. I'll ping you in terms of what's best. I got to figure out what my kids need to get picked up and stuff, but I might bring my son. Maybe like 4 o'clock or so. I might be able to bring my son with me, who's interested in this stuff.
Cool.
So I'll try to do that. All right, cool. This is great. All right, guys, we're getting there. All right, catch you later. Thanks, Ling, for everything and all the thought.
Yeah.
Thanks.
You guys ping me.
Thank you.
Yep.
Thank
Bye,
you all.
guys.